Hello everyone, welcome to DSP NIT Andhra. I am Sushma Sai Mannava from 4th year ECE. In this video, we will see about regional descriptors. Before that, let us first understand what actually descriptors mean. Image descriptors are descriptions of the visual features of the contents in an image. They describe elementary characteristics such as shape, color, texture, or the motion among the others. Regional descriptors describe regions or areas. Let us see some of the simple descriptors. The area of the region is described by the number of the pixels in the region. The perimeter of the region is described by the length of its boundary. The compactness of the region is given by perimeter square by area. Mean and median of the grayscale levels, where mean is the average of the pixels intensity value within the region and median is the median of the pixel intensity value within the region. The minimum and maximum gray level values, the number of pixels with values above and below the mean. Here, figure 1 shows the infrared image of America at night. The table alongside the image shows the percentage of lights per region to that of the total lights. Here, if we observe the table, we can say that the region 2 have the highest percentage, which means it has more lights compared to the remaining 3 regions. So, we can say that the region 2 has more electrical energy consumption. Coming to the topological descriptors, topology is the study of the properties of a figure that are unaffected by any deformation except tearing or folding. Topological features gives a global description of a region like number of holes, number of connected components, number of edges, faces, vertices, etc. These properties do not depend on the distance. Topological property 1, number of holes. In the figure 2, the white region indicates the holes. Here we have 2 white regions, which means 2 holes. So we can say that it is a region with 2 holes. Topological property 2, number of connected components. In the figure 3, the shaded region indicates connected components. So we can say that it's a region with 3 connected components. Topological property 3, Euler number. Euler number is given as the number of connected components subtract the number of holes. That is E equal to C minus H, where C is the number of connected components, H is the number of holes. In figure 4, for letter A, it has 1 hole and 1 connected component, which means E equal to C minus H, that is 1 minus 1, that is 0. For the letter B, it has 2 holes and 1 connected component, which means E equal to C minus H, that is 1 minus 2 minus 1. So we can say that letter A has Euler number 0 and letter B has Euler number minus 1. The Euler number can be applied to the straight line segments such as polygon network. For the given figure 5, which is a polygon network, Euler formula is given as V minus Q plus F, where V is the number of vertices, Q is the number of edges, F is the number of faces. For this network, it has 7 vertices, 11 edges and 2 faces, 1 connected region and 3 holes. So Euler number is given as 7 minus 11 plus 2, which is minus 2. Coming to this figure shows the image of the Washington DC. Suppose that we want to segment the river using only this image. Since the image is a rather dark, uniform region of the image, thresholding is an obvious thing to try. The result of thresholding the image with the highest possible threshold value before the river became a disconnected region is shown in the figure D. The threshold was selected manually to illustrate the point that it would be impossible in this case to segment the river by itself without other region of the image. The figure C shows the connected component with the largest number of elements. This is the desired result, which we already know cannot be segmented by itself from the image using threshold. If we want to perform measurements like length of each branch of a river, we could use skeleton of the connected component, which is figure D. In other words, the length of each branch in a skeleton would be reasonably close approximation to the length of the branch it represents. Now let us analyze the thresholding in a MATLAB. So what actually thresholding means? It is converting any image to a binary image. How will we convert? The idea is very simple. Deciding some particular threshold, any pixel intensity above that particular threshold maps to 0 or 1, and pixel intensity below that particular threshold maps to reverse bit. Here, decision of thresholding is very important. So for this particular purpose, taking the required image, here we take the required image, converting it RGB to gray here. I am show of X shows the image. I am pixel info gives the pixel information at any particular XY point. Here we want to segregate the river. So if we observe that the capture and the intensity values of this image. The whole river has the intensity value less than 0.3. See, less than 0.3. So we consider here threshold as a 0.3. So we take a threshold as 0.3. Deciding the number of rows and columns present in the image, creating the 1-0 matrix of same size where our binary image will be stored. Then using the for loop for traversing the image, each time if the intensity is greater than threshold, I am mapping it to 0 since we need river to get highlighted. If it is not greater than threshold, then we are mapping it to the 1. If we run and we'll see, if we take the threshold value 0.3 and if we perform threshold, we'll get it as this. So in this way, we perform thresholding. Thank you.